Every hurricane you've ever watched come ashore had one thing in common. The water left. It rose, it took what it was going to take, and then it drained back out to sea. The cameras went home, the rebuilding started. That's what a storm surge is. It's a visit. However violent it gets, the ocean eventually returns to where it was, and the line on the map that separates land from water goes back to being the line it always was. There is one flood threat to the United States that does not work that way at all, though. It's not a storm. It will never appear on a forecast cone. It's a single glacier in West Antarctica, on the other side of the planet from the American coastline. It's larger than the entire state of Florida. It's shedding roughly 50 billion tons of ice every year, more than the snow falling it can replace. It's already responsible for about 4% of all the sea level rise happening on the planet right now. And the floating slab of ice that has been acting as its brake pedal is, according to a marine geophysicist at the British Antarctic Survey, very likely to break apart this year. Its name is Thwaites. The press gave it a nickname, the Doomsday Glacier, and that nickname has done enormous damage to public understanding in both directions. So today, we're going to walk through what this glacier actually is, the strange physics that makes it different from every other block of ice on Earth, what a robot found when it was lowered underneath it, and the counterintuitive reason ice melting in Antarctica raises the water on the American East Coast more than it raises the global average. Not a countdown, not a date, the mechanism, the evidence, and the honest limits of what anyone can say. Now, before we go south, I want to hear from you, because a very large number of you are watching this from somewhere that the ocean has already made an opinion about. Here's my question for you in the comments. Have you personally watched water get somewhere it was not supposed to be on any grander scale? A street that floods now on a sunny day when it never used to before? Maybe a yard that takes a week to drain after a storm that would not have touched it 20 years ago? Tell me the town and what changed for you there, because the people living that kind of flooding describe it far better than any projection chart does. And if this is the sort of breakdown that you want more of, the like button is what decides whether it reaches somebody standing on a coastline who's never heard about any of this. I'm not going to ask you for a specific number. Just tap it if you think the video earns it. And if you want the rest of this work all together, subscribe to Critical Latitude. What I'll promise in exchange is that every figure here is attributed to the agency or the journal that published it. And I'll tell you plainly when the scientists disagree, instead of picking the version that sounds more dramatic. And that when a study gets revised, I'll come back and say so. So let's start with the object itself, because most people have heard the nickname without ever being told the dimensions. Thwaites Glacier sits in West Antarctica, draining into a stretch of ocean called the Amundsen Sea. Its drainage basin covers about 192,000 square kilometers, roughly 74,000 square miles. That makes it larger than Florida, close to the size of Great Britain. Where it meets the sea, it's about 120 kilometers across, roughly 80 miles, which makes it the widest glacier on Earth. Not one of the widest, the widest. Stand at one edge of the ice front and look toward the other, you'd not be able to see the other end of it. And it is thick. Where the base of the glacier finally lifts off the seafloor and begins to float, the water underneath is somewhere between 800 and 1,200 meters deep. Hold on to that detail because it's the single fact that separates Thwaites from a glacier in Alaska or Switzerland. Now, the numbers that earned the nickname. If Thwaites collapsed entirely, global sea level would rise by about 65 centimeters, 25 inches, or call it 2 feet, everywhere on Earth permanently. That figure alone is serious, but it's survivable. It's the second number that makes scientists more uncomfortable. Thwaites is not standing on its own. It functions as a buttress for a much larger body of ice behind it, the West Antarctic ice sheet. If that entire ice sheet were to go, global sea levels would rise about 3.3 meters, or 11 feet. Now, I want to be careful here because this is the exact point where most videos about this glacier stop being honest with you. Nobody serious is telling you 11 feet is coming up this century. That full ice sheet collapse is understood as a process that would take centuries to millennia. It's not a forecast, it's a ceiling. It matters because it tells you what is stacked behind the door, and Thwaites is that door. So why this glacier out of the hundreds of others on a continent made of ice? The answer is the shape of the ground underneath it, and it's genuinely strange to think about. When you picture a glacier, you probably picture ice sliding down a valley, sitting on a rock that gets higher behind it and lower in front of it. That's a normal glacier on a slope that runs downhill towards the sea, but Thwaites does not do that. Thwaites sits on a bed that is below sea level, and that bed gets deeper the further inland you go. The ground under this glacier does not rise as you move away from the ocean. It drops. Geologists call this a retrograde slope, and it turns the whole system into something closer to a bowl. Now here's why that shape matters so much. The place where a glacier stops resting on solid ground and starts floating on seawater is called the grounding line. It's the hinge of the entire system. On a normal glacier, if the grounding line retreats inland, it retreats onto shallower ground, so less ice is exposed to seawater and the retreat tends to slow itself down. The geometry works against the collapse. On a retrograde slope, everything runs the other way. Retreat inland means retreat into deeper water, which means a taller face of ice exposed to the ocean, which means more melting, which pushes the grounding line further inland into water that is deeper still. Each step makes the next step easier, and scientists call this marine ice sheet instability. And the plain language version is that once this process gets far enough, it stops needing a push, and it feeds itself. And there is something down there feeding it. The water in the Edmundson Sea is not the freezing surface water that you might be picturing. A deep, relatively warm, salty layer called circumpolar deep water sits below the cold surface layer. It's been finding its way along the seafloor and up underneath the glacier, into the cavity between the ice and the rock. This glacier is not primarily being melted from above by warm air, it's being melted from underneath by ocean water in the dark, in a place no human being has ever seen. Until a group of scientists decided they wanted to go look. So this brings us early 2023. 2 papers in the Journal of Nature described what happened when a team drilled a borehole 600 meters straight down through the ice and lowered a torpedo-shaped robot called Icefin into the cavity below. It was the first direct look at the grounding line of Thwaites, and what it found was not what the models had predicted at all. Across the broad, flat underside of the ice, the melting was actually slower than expected, somewhere in the range of 6 to 18 feet a year, less than the models had assumed. If you stopped there, you would think, oh, this is good news. But the underside of the glacier turned out not to be flat at all. It's a carved, irregular landscape of terraces that look like staircases and deep crevices cut up into the ice. On the steep walls of those features, the melting was dramatically faster. The heat was not spread evenly across a smooth ceiling. It was concentrated sideways into the cracks. Over the 9 months the instruments recorded, the water in that cavity got warmer and saltier and stayed well above freezing through most of the space, which means there was always heat available to melt the ice. The conclusion the researchers drew is the part worth carrying with you. The most important thing happening under Thwaites is not slow, uniform melting, it's fracture. It is the ocean working its way into cracks and widening them, and that does more damage to the structure of this glacier than the melt rate alone would ever suggest. The glacier is not dissolving like a sugar cube does. It's being taken apart along its seams. Which brings us to what is happening right now in this year and why this video exists today rather than a year from now. Thwaites has a floating extension out in front of it called the Thwaites Eastern Ice Shelf. Think of it as a slab of ice no longer resting on the seafloor, jammed sideways against an underwater ridge. It doesn't add to the sea level because it's already floating, and floating ice displaces its own weight, right? That's where a lot of people get confused, so let me say it really clearly. The ice shelf itself is not the flood risk we're worried about. The ice shelf is the break. Because it's wedged against that submerged ridge, a feature scientists call a pinning point. It pushes back against the glacier behind it and slows the rate at which land ice slides into the ocean. Take the break away and the ice behind it accelerates. That's the entire concern. In December of 2021, at the American Geophysical Union meeting, a glaciologist named Aaron Pettit of Oregon State University presented work showing fractures spreading across this ice shelf faster than anyone had expected, and warned it could shatter within as little as 5 years. That warning got picked up everywhere, usually stripped of its caveats, and it's the origin of most of the alarming headlines you might have seen since. Well, 5 years have now passed, and here's the accounting. The shelf did not shatter in that window. It did not stabilize either, though. Between January 2020 and January 2026, the speed at which that ice shelf flows tripled, reaching just over 2,000 meters per year. Huge fractures have opened around the pinning point and along the grounding line. On the western side, the movement has roughly doubled in the last 8 months alone, and Robert Larter, a marine geophysicist at the British Antarctic Survey, has now said the shelf is very likely to break up in 2026, this year. So the 2021 warning was not wrong about the direction. It was early on the timing by a few years, on a system where a few years is really nothing in the grand scheme of things. That's worth understanding about the entire field of science here. The scientists are usually right about what is happening, much less precise about when it happens. Now let me put this next to a hurricane, because that comparison is the whole reason this video is titled the way it is. It's not a rhetorical trick, it's a real difference in kind. Hurricane Katrina generated a storm surge that overwhelmed New Orleans and killed more than 1,000 people. Hurricane Sandy pushed water into the New York subway system. In raw destructive power, those events are far beyond anything a glacier will do to you in your lifetime. A hurricane can take a city apart in 8 hours. Sea level rising cannot do that. On speed and violence, the storm wins, and it's not close. But run the clock forward, and the comparison inverts completely. A storm surge is a temporary borrowing of the coastline. the water goes back, the claims get filed, the debris gets hauled out, the town gets rebuilt on the same lots, and life will resume on the same map. Sea level rise does not give the land back. There's no draining phase to it. When the ocean comes up 2 inches, it's about 2 inches at every high tide, every storm, every full moon. As for the rest of human history, as far as anyone planning a city needs to care, it does not destroy a neighborhood, it reclassifies it. Now here's the part that does the real damage. Sea level rise does not act alone. It acts as a floor under every storm that follows. So raise the baseline by a foot, and every hurricane that arrives afterward starts its surge a foot higher, over defenses that were designed and financed against the old number. It's the same storm, unchanged in strength, reaches further inland than it would have before. Sea level rise does not replace hurricanes as a threat. It upgrades all of them at once, permanently, without ever appearing on a radar screen. So that's the first half of the answer to why this is worse than you might think. Here's the second half, and this one is genuinely counterintuitive. You would reasonably assume that ice melting in Antarctica raises the ocean evenly, or that it would raise it most in the places that are nearest to Antarctica. Both of those assumptions are wrong, and the reason is gravity. You would reasonably assume that ice melting in Antarctica raises the ocean evenly, or that it would raise it most in the places nearest to Antarctica, right? Both of those assumptions are wrong, and the reason is gravity. An ice sheet is an enormous concentration of mass, and mass exerts gravitational pull. The Antarctic ice sheet is physically pulling the surrounding ocean towards itself, holding a bulge of water around the continent. Now, when that ice sheet loses mass, it loses some of that pull, and the water it was holding close redistributes across the rest of the planet. This is called a sea level fingerprint. It produces a result that sounds impossible the first time you hear it. When the Antarctic ice melts, sea level near Antarctica falls. The rise shows up thousands of miles away. And the American coastline sits in one of the places where it shows up hardest. According to NASA, when the Edmundston Sea sector of the West Antarctic ice sheet is totally gone, the average global sea level will rise about 4 feet. But the east coast of the United States will see an additional 14 to 15 inches above that average. Think about that, because it inverts the intuition completely. This is the sector Thwaites belongs to. In that scenario, the world gets 4 feet, and the American East Coast gets more than 5 feet. The US is not a bystander to Antarctic ice loss. It's one of the places that gets it worse than the global number implies. And the mechanism is not weather or currents or bad luck. It's the gravitational field of a continent of ice on the far side of the planet slackening its grip. None of that is a future problem that you get to file away, because the American coastline is already moving without any help from Thwaites either. The Federal Sea Level Rise Technical Report, produced by NOAA, together with several other agencies, projects the U.S. coastline will see an additional 10 to 12 inches of sea level rise by the year 2050. This country is on track to experience as much sea level rise in the next 30 years as it did in the previous 100 years. Now here's what a foot actually does, because a foot might sound like nothing. You could step over a foot. The problem is that coastlines do not experience averages. They experience the worst day of the month. Under that projection, flooding along the American coast is expected to occur more than 10 times as often as it does today. By the year 2050, a high tide flooding is projected to happen between 45 and 85 days a year, depending on your location. Charleston, South Carolina sits in a range of roughly 45 to 115 days, and the Norfolk area in Virginia is projected to see something closer to 100. 100 days out of your year. That's not a disaster. Nobody deploys the National Guard for high tide. It's water in the street on more than a quarter of the days in the year, with no storm involved, in a city that was not designed for it. It's the kind of flooding that doesn't kill people, and it does quietly kill property values, insurance markets, road surfaces, septic systems, and the tax base that pays for fixing any of it. That projection is essentially the baseline. It's what happens with the ice loss already underway. Thwaites is the thing that could sit on top of it. So, let's ask the direct question and answer it with the science rather than the thrill of it. Is Thwaites Glacier about to collapse? Is Miami going underwater in the next decade? The honest scientific answer is no, and you should hear that plainly, because you'll not get it from most videos with the glacier in the thumbnail. There's no evidence that Thwaites has entered a runaway collapse. So that's the good news. A full collapse is not expected in the coming decades. The most likely path is that this glacier keeps retreating faster than it used to through the 21st century and into the 22nd, with the truly enormous outcomes measured in centuries. And in one specific way, the science has actually moved in a reassuring direction, which is exactly the kind of update that never gets a headline. And in one specific way, the science has actually moved in a reassuring direction, which is exactly the kind of update that never gets a headline. There was a hypothesis called marine ice cliff instability. The idea was that once the floating ice shelves are gone, you're left with towering cliffs of ice exposed at the coast, so tall they could not support their own weight. They would crumble exposing a new cliff behind them, which would crumble in turn, and the collapse would run inland like a row of dominoes. That hypothesis produced the most terrifying sea level projections of the last decade. In the year 2024, a study published in Science Advances, led by Mathieu Morlighem of Dartmouth College, tested it using 3 separate high-resolution ice sheet models. The finding was that ice cliffs need to reach around 100 to 35 meters, roughly 440 feet, before that kind of systemic failure begins, and that they fail far more gradually than the hypothesis assumed. When the team simulated a total collapse of the floating ice today, all 3 models showed Thwaites remaining fairly stable, at least through the year 2100. The domino scenario for this century does not appear to hold up. That is a real correction, and it deserves to be said out loud. But listen to what the author of the study said next, because this is where honesty cuts in the other direction. Marine ice cliff instability, in his words, is only one mechanism of ice loss, and the finding does not mean Thwaites is stable. Now, what that study removed was the fastest possible route to catastrophe. It didn't remove the destination. The ocean is still warm underneath. The bed still slopes the wrong way, and the fractures are still spreading. The grounding line is still retreating, and along the Edmundston Sea coast, the ice is withdrawn by as much as 42 kilometers in places. Thwaites is losing ice more than 5 times faster than it was in the 1990s, and it shed more than 1,000 billion tons since the year 2000. One modeling study published in March 2026 projects that by 2067, this single glacier could be losing between 180 and 200 gigatons a year, roughly comparable to what the entire Antarctic ice sheet is losing today. So the accurate summary is not that the danger was canceled, but the mechanism has changed, and the clock got longer. The direction did not change at all. And a slower catastrophe is not a smaller one. It's one that arrives on a schedule no election cycle, no 30-year mortgage, no municipal bond was ever built to think about. Now, as for what happens next, the answer is in the measurement. The International Thwaites Glacier Collaboration, that's a joint effort between American and British research programs, has spent years putting instruments on and under this glacier precisely because it was the largest hole in our ability to forecast sea level. Satellites track the grounding line and the flow speed. Boreholes and robots sample the cavity underneath. The thing to watch over the coming months is the eastern ice shelf and its pinning point. Because if that shelf does break up this year, what scientists will be watching for immediately afterward is how much the glacier behind it speeds up and how fast. That number, measured rather than modeled out, will do more to sharpen the sea level projections for the American coast than any argument on the internet ever will. Okay, so now let's get to what you can actually control, because information without action attached to it is just a heavier kind of worry, and for once this is a hazard where the practical steps are unusually concrete for you. Now you can go find out your elevation and your flood zone. Not your neighborhood's, but yours. FEMA publishes flood maps, and NOAA publishes coastal flooding viewers that let you see what a given amount of water does to your specific address. Most people who live near water have never once looked, and the ones who assume that they're fine are frequently wrong by a margin that matters. Understand that a standard homeowner's policy does not cover flood damage. It never has. Flood coverage is a separate purchase, and there's typically a 30-day waiting period before a new policy takes effect, which means the week a storm is in the forecast is the week it's already too late. That's a conversation to have in a calm month, not a hurricane week. Now, if you're buying on the coast, ask for the elevation certificate and ask about the property's flood history rather than its flood zone alone. Zones can get redrawn, but water does not consult them. And if you are a renter, or if the property decisions are out of your hands for some other reason, the thing you can control is the go bag in your plan. You need documents, maybe medications, water, a way to charge your phone, and one meeting point that everyone in your household knows without needing to be reminded. The hardest part is not any single step. It's keeping the whole of it for every hazard that your region actually faces, in one place your family can find when the power is out. And that's why the Emergency Preparedness Guide linked in the description exists. It covers flooding alongside the hurricanes, power outages, and evacuations that coastal residents already live with. It has fill-in pages that are easy for you for your documents, contacts, and medications. And if you'd rather build the same thing for yourself over one focused afternoon with your notebooks, that's fine. You can do that instead. But what matters is that it exists before the water arrives and not after. Okay, here's the final thought I want you to carry out of this video. We've organized our entire relationship with the ocean around events, hurricane seasons, evacuation orders, landfall, the moment the storm passes and the counting begins. Every institution we built for coastal risk assumes the water comes and then the water goes, and that map on the other side is the same map. Insurance is priced that way, building codes are written that way, mortgages are underwritten that way, and cities are planned that way. But Thwaites Glacier does not care about any of that because it's not an event happening. There's no landfall and there's no all clear. There's no moment when the water goes back out and the counting starts because The counting never stops. And that's the difference the title of this video was pointing at. A hurricane is an ocean that's visiting. This is the ocean moving in. The first one is a catastrophe you survive and rebuild from, but the second one is not a catastrophe at all in any way that we know how to recognize. That's precisely why it will beat us. It's slow enough for us to ignore, and permanent enough that ignoring it compounds, and driven by a piece of ice so far away that no American will ever see it with their own eyes. Now, we're going to stay on this one as it develops, particularly through the coming months, when the eastern ice shelf either breaks apart or it doesn't, and whatever the satellites measure afterwards. If it breaks, I'll tell you what actually changed rather than what it makes people feel. If it does hold, I'll tell you that too. Now, I want you to go back up and answer the question I gave before, because I do read through these comments. Where do you live, and has the water started showing up somewhere it never used to before? Those answers are the ground truth underneath every projection in this video. Look after the people around you, find out what your address sits at above sea level, and do it this week, rather than the week that you really need it. Stay safe, and I'll see you in the next one.